So we're going to add Letrec to our book language. I'm also going to add back in if0 because that's a handy thing to have to write interesting recursive functions. We're going to have let in our language, but now we are going to treat it as sugar that expands away to lambda. So it's in our concrete syntax, but our interp won't have to deal with let specifically. It will have to deal with if0 and, of course, letrec. If0 is straightforward, and letrec is as we just discussed. So when we have a name on the right-hand side and a body, then we start by constructing the new environment that's needed both on the right-hand side and in the body. And we extend it to have a binding for the name n, where we have a lambda as in place of the value that will get the value on demand later. Meanwhile, we compute the value as the result of interpreting the right-hand side in that new environment, and finally we interpret the body in the new environment. And the implementation looks like this. I'll just pause to note the implementation of let here, which produces an apc of a lambc. Right? That's our syntactic desugaring. Right? But we have letrec that looks just like the parsing of let used to look. And we have letrec c here as we had it on the slide. So I have a bunch of tests for this language that you can look at later. This is letrec MC for metacircular. And I'll just demonstrate that we can use our interpreter to compute factorial. So here we have letrec of fac is a function that checks whether x is 0, returns 1, otherwise it calls itself recursively. And we started off with 5, and so we get the number 120. And we can also do some of the simpler examples, like letrec of x is 10 and plus x1. Okay. This expression, of course, would be the same as using let, because I'm not actually using x on the right-hand side. We can check the broken example, where we define x to be x and x. What should we get back here? Because our interpreter is built on top of letrec for PLAI type, then we get the same thing as for PLAI type. We get an undefined result. So that's good in the sense that we are getting this sort of consistent thing that we expected. On the other hand, it really emphasizes how all of the interesting detail of handling letrec and dealing with undefines is hidden inside of PLAI type so far. So I'd really like to take more control over the implementation of letrec.